In a previous video, I showed how I got a 500 gram weight and a silver bar and a scale, and then traveled across 3 different spots in the United States and tested the different weights out. I calibrated the scale in Phoenix, Arizona, and this video is showing you the results of that. The idea behind this was we are told by mainstream science that the further north you go, the more you will weigh, because the centrifugal spin of the Earth has less effect on you as you head further north. So this video is to show the results of that, which I think you're going to find are actually pretty surprising. Now here are the places that I actually did the experiments. Phoenix, which is where I live down here. And what I did was I came over here, and these are all just approximate locations. I want to show you what we should expect from this experiment. The farther north we go, the less the centrifugal force of the spin of the Earth, if it is spinning, should have, which means the weight should get heavier as we head farther north. Now the distance between Phoenix and Baltimore, which is right where this little diamond is right here, is approximately this right here. So that was the greatest distance, the first one, the greatest distance change, from 33 degrees north up to, I think it's 42. We'll look at it here in a second. Then from Baltimore to New York north, I was right about it here in the Albany area where I did my experiments there. And then, as you can see, the last place is Chicago. Now Chicago is right between Baltimore and New York. It's actually almost right in between them. So let me shrink this down, the distance between Baltimore and New York. Remember, it's just the latitude. We're not worried about the longitude difference. At least not initially. They should have nothing to do with it, but that may come into one of my theories. We'll see. So half of this distance right here, Baltimore, it's actually, you know what, it's almost right in between. It really is. So what we should have is our first jump from down here. We should go from the heaviest weight, 500 grams, or I'm sorry, the lightest weight, 500 grams. Baltimore should see the biggest jump increase, and this is going to be our base that we use right here, this right here. And then we should see the weight get a little bit heavier as we get up to New York. Not quite as big of a change between Phoenix and Baltimore. And then in Chicago, it should actually get a little bit lighter. It should be in between the weight of Baltimore and New York. So let's take a look at what we actually have here. All right, here's the spreadsheet I used to get predicted model for what we should have. The way it works is the equator should be the lightest weight, and as we head up to the pole, each degree should be the exact same additive amount that the weight should weigh because of lessening centrifugal force. This should be a even weight per degree all the way up, unless somebody's got ideas otherwise. I don't think it should be any kind of geometric number or whatever. It should be absolutely linear as we go up, because we don't have any all of a sudden jumps in the so-called speed of the Earth if you're down at the equator versus let's say 50 degrees north. So what we did was all these yellow boxes, they indicate the base number. We started in Phoenix, which my location was 33.382 degrees north latitude. We used a 500 gram weight, and that's what it weighed. And again, there was very small variations with all these numbers, but these are pretty much the accurate numbers. So 500 gram weight in Phoenix. And then we go to Baltimore. So we left Phoenix, which is this latitude here, went up to Baltimore. That was a change of 6.054 degrees from the base, from this latitude right here. Here's the Baltimore latitude, 39.436. So here's the change. Now each degree on the Earth for latitude equals 69 miles. So we take the mile change. So from Phoenix to Baltimore, this is a north change, and not east-west. We're only interested in north-south for now. East-west may come into a little bit of our prognostication later. But anyway, we are moving 417.726 north. This is the exact latitude where I took the measurement there, the weight in Baltimore was 500.17 grams. So we added 0.17 grams. Now from that, we're going to use this as our predicted weight. This is our base. So from 500 to 500.17, it's a change of 0.17 per 6.054 degree change on the Earth. So I did the math down here, and when you divide that down into per degree, the weight change per degree heading north should be 0.28080 on and on here per degree heading north from the base. So every degree we head north, this has how much more the 500 gram weight should weigh as we head towards the pole. And so that gives us a predicted weight of 500.17. Our actual weight was 500.17. No difference. This is our prediction. Then Chicago, that's the next farthest north. You can see here from 39.4 to 41.97 degrees. And the change here is 8.595 degrees from the base, which is Phoenix, which is 593 miles north of Phoenix. So what we do is, if you want to look at these other things I calculated here, you can. I will click here slowly but surely so you can pause. So we go to Chicago, and now we can predict, since we have a base that we can go from. So using the same number and multiplying it by the amount of degrees change from Phoenix, we should have it should weigh 500.24 grams. The actual weight was 500.42 grams. So it's weighing more than it should in Chicago. And you would think, oh, it's just, maybe it is exponential a little bit. Well, wait. The actual weight was this much, so we had a 0.1786 grams too much weight in Chicago. Watch what happens when we get to New York. New York is only, 1.2 degrees roughly farther north than Chicago. Here's the base degree change from Phoenix, 9.365 degrees, or 646.185 miles farther north than Phoenix, latitude speaking. And that gives us, multiplying that by this number here, it's a predicted weight of 500.26. So it should be the heaviest in New York, the farthest north, right? Well, guess what? It was 500.36. It was lighter than Chicago. So there's something else going on here. And the difference here was it's actually closer to the base than Chicago was. Now, I have thought this through. I think we need to get raw barometric pressure, which means not adjusted for sea level. And I'll explain that in other videos if people want to talk about doing this some more, to see if that's a change. And I also, this area up in here where my cursor is roughly where the magnetic north is for our area. Does magnetics have something to do with New York being closer and Chicago? I don't know. I don't know which one's closer. And how much does air pressure have to do with it? I don't know, if any. But this, I mean, it seems to follow the Earth model spinning at first, but then it totally falls apart. This number should be gradually getting larger, not larger than smaller again. So at first blush, yeah, it seems like it all works out. I'm glad I did 3. I was just going to do 2, Baltimore and New York. I'm glad I decided to do Chicago in between. But there's a difference here. Now the different areas had different heights above sea level. That's in the previous picture that we looked at. Let me see if I can get that one here. Yeah, 298 feet was Baltimore. 275 feet was New York. Pretty much no change there. Chicago didn't list the altitude, but I did look that up before, and I think it was 600 feet. I'm not positive about that. So I don't know. These are other things that we can possibly look at, but the bottom line is it didn't work out for a non-moving Earth, and it didn't work for a moving Earth. Something else is affecting the weights. So unless further research indicates something different, and I plan on traveling to Europe next year, and maybe I should do this. You think I should do this through going through Europe as well? So anyway, give me your thoughts. This is what my results were. My results indicate we're not spinning at all, because if we are, that's not what's causing the weight change, or at least, let me rephrase that. This is not proof that we are spinning or not moving, but it is proof that what they say is false, which is the further north you go, the lighter something will be. That's false, because these differences are not linear. They're actually, they jump around. So something else is causing slight variations, and maybe what I'll do is order another 500 gram weight so we can test 1,000 grams. Maybe that's why the silver, because it was lighter, didn't show that much difference. Or maybe because the 500 is a gram, probably has ferrous metal in it. I don't know. But the one thing that's debunked here is the further north you go, the heavier you will weigh. That's BS. God bless, guys. Take care.